Wonderful. All right. So this briefing is unclass, and I'm going to keep it that way. My intention is that if you want to go back and look anything up, I'll post this video. I'll also make sure that I've made a little spreadsheet for you that shows all the things that I'm about to show on here, and you can go look it up if you're studying for any of the IW or EW stuff. I'll link to all that off of my website, so that's doug@tl.com, and you can just go there, and I'll post up the links for it and everything in a bit. Okay, so today I'm going to cover the OSI model, which is a international standard organization model for how the internet works, how we send data from one computer to another computer. Right, it consists of 7 layers, and they're all impenetrable and really difficult to understand when you first look at them. But my intention is to make this Marine-proof, because I'm a Marine. If I learned it, then it's possible for others to learn it. So I'm going to draw a mental analogy to 13 days over here. So 13 days being the Cuban Missile Crisis, and the bits about U.S. history that you know, and draw a direct analogy between the U.S. mail system and communication between Nikita Khrushchev and President Kennedy. And we'll work through this example first, and then I'll explain to you how it works in computer terms, all right? So, those of you who are studying for the test, do you remember what the 7 layers are? So 4, 3, 2. Does anybody remember the mnemonic, at least, for what they are?
One's the application layer.
Yep, that's right. Application is up top. So I'll give you the starting letters. Sorry, I missed one. P, T, okay. All right, there's your first letter. Okay, so let's work through this with the 13 days analogy. Now, situation here is 1962. Kennedy gets a brief that the Russians are putting medium-range ballistic missiles into Cuba. This becomes a bad thing for us because it reduces the warning timeline before we get nailed with a nuclear weapon. Obviously not a great thing to do. All right, so this is where all of the real thinking goes on, is at this application layer, right? This is on a web browser, something like your web browser or like your Skype app, or even an application like Excel or Word or what have you, if those were networked applications. Basically, this is where you interact with the computer, all right? So right up here, this is, let's call it the NSC, the National Security Council. This is where we're making a decision about what's going to happen and what we're going to do next, just as you get to your web page and then you decide where you're going to go next after that. And then you click through to your Gmail, and then you click through to weirdporn.com or whatever, you know, up to you. All right, okay, so that's your first layer. That's where the decisions are going on. Next layer is your presentation layer. So, President Kennedy was a smart guy, but he didn't speak Russian, not fluently anyways. So, what do we need to do but translate his letters, and this is 1962. He's physically writing letters to Nikita Khrushchev saying, I would really encourage you to, you know, not put medium-range ballistic missiles there. I'm going to have to take our Navy and start blockading the island, and we're going to need to prevent this from escalating. So at the presidential level, he makes a decision up here. He decides to write a letter, but that needs to get translated, right? So the same thing happens for computers. Okay? You need to translate from a format that one computer understands to another. A Mac might have a different bit length for integers than other computer types, or you might be working on a Unix operating system, what have you. This layer here is what does that translation, just like humans to humans. Okay? Your next thing is your session layer. All right? So a session layer, this is kind of like, well, we decided that we needed this in the Cuban Missile Crisis. We needed to create an issue-specific forum to deal with this issue. Although we met with the Russians in the United Nations. We're both sitting on the Security Council. We had plenty of mill-mill talks. We had plenty of Paul-mill dialogues, that kind of stuff. This was an emergent issue that was so unique and so powerful that we needed to have something that just said, all right, on this specific issue, I need to talk to only Nikita Khrushchev. I need to make sure that I have really clear lines of communication between him and me, despite, you know, our respective ministers of defense and secretary of defenses doing their thing, or Bobby Kennedy going off and trying to establish back-channel communications with the Russians and what have you. The session layer is what ties all of those communications together so that up at the higher level, we can unify everything, all right? So in our computer analogy, what's going on here? Say that you have a video conference. Well, you ever had that weird thing where like the mouth is ahead of the audio? Well, that's poor sessionization, right? Basically, we're not binding together the different communication channels in the way that they're supposed to be bound together. But that's what we got to do here, all right? So let's just call this something like the red phone, right? Or this specific dialogue. Okay? All right? Okay. Next thing is a transport layer. Okay, the transport layer, this layer is responsible for, and it's worth saying here, President Kennedy didn't have any visibility on these lower layers. Much like you as an internet user don't really pay much attention to what's going on in these lower layers. All you know is you click something on the internet and all this stuff just happens. These layers are exactly the same way. They don't know that these other layers exist. All that they do is try and communicate laterally to a similar layer on another computer, right? So they know that I got this in Russian, so I'm going to send something back out in Russian, or I'm going to do some type of encryption here, and I'm going to expect that the other computer de-encrypts. But as far as they're concerned, the presentation layer doesn't really know that there is something down here called a physical layer, which we'll get to in a bit, okay? So these are what we would call layers of abstraction, all right? The next layer is the transport layer. The transport layer is, it defines what type of communication we're going to have, right? So in the case of this, let me make sure that I'm following the thing that I talked about, or that I wrote this morning. This is what I said. Certified mail. All right. So again, 1962, we're talking about literally sending a letter from Kennedy to Moscow every day. It takes about 24 hours for them to get there. What he certainly wanted to make sure is that he got a return receipt from each of those, like, okay, no, Nikita Khrushchev actually got this. Here was the signed receipt from his secretary that he got it, right? We do exactly the same thing on the internet. When you send a bit of information, you get a checksum, you do some validation, and you send a response back that says, okay, everything's been received, everything is good. We call that TCP packet verification. You can, in some instances, not request that. You don't have to request certified mail. For instance, again, video conferencing. It's more important that you just push a lot of data through that video conference than that you verify that every little bit of data was perfectly rendered and that, you know, he didn't have a little pixelation on his right eyebrow or something like that. So we have another protocol for that. We can choose different protocols here, just like you can, like Kennedy and Khrushchev could have chosen different mail formats for how they communicate back and forth, okay? All right, network. Now this is really almost perfectly analogous to the traditional mail system, okay? It's just an extraordinarily fast mail system. The network has a return address and a send address, just like Kennedy and Khrushchev would have said, all right, if you can't get this letter to Khrushchev, I want you to send it back to, 1600 Pennsylvania Avenue, I think it is, and I want to know about it, right? So this is just to and from. And just like your mail, that's readable to everybody on the internet. Who you send stuff to and who you receive from is available, and just like the regular postal mail, where we're allowed to send with various caveats, various levels of classified information via the standard post office, you can do the same here. You deal with encryption up here or here, but the actual postal codes on those, that's available for everybody to see. You can do things like wrap envelopes inside of envelopes, just like you can in the physical world. So you could, there's a place out in Wyoming, I think, called Noel, where you send them a card, and then they'll pull out your envelope and stamp it in OL and send it back to you, a self-addressed stamped envelope they used to do, when we had infomercials coming out. You can do exactly the same thing here, and that is what a VPN is. It's wrapping envelopes inside of envelopes, and then you pull them out when you get there, and then you send the next one along the way, if you don't want your stuff to be read by the public routers. Okay? The next thing that we're looking at is the data link layer. Okay? Now, this is the analogy again to the postman. That guy who gets the letter from President Kennedy, he's going to take it and put it in a mailbox, and he's going to take his little mailbox to a bigger mailbox, and they're going to encapsulate it inside of a bigger mailbox, and they're going to put it on a plane, and that plane is going to go to Moscow, and that plane is going to break it back down into exactly the same thing happens here. But this is like your postal internal routing. So from your perspective, you don't really care, right? You don't care how the postman gets it. You just want it to get there as fast as possible based on whatever certified mail or whatever type of mail you've requested. Same thing here. This layer is completely abstracted away from us, but this is how, this is where your machine address codes come in. So each device has a little code on it that says, all right, I am this 64-bit identifier. If I connect to a given hub, then you're going to know that I'm here, and if you're trying to find me, then you can send on this layer to get to me, okay? So same deal here. All right, and this last layer is the physical layer. Okay, and this is literally the postman carrying it. Okay, and on the internet, works just the same way. Okay, you can, because of the world that we live in, this is no longer amazing to those of you who are younger than me, but like the idea that you can seamlessly move from Wi-Fi to a cellular network to a different Wi-Fi network and still be able to access your Gmail or access whatever other applications you have is a little bit of magic, right? And this is how that happens, because we've abstracted away from the physical layer. It doesn't matter if you're sending these little packets of mail via a wireless signal or via an Ethernet signal or via whatever. They come back in the same form that the data link layer can then address. Okay, so here's your National Security Council example. Right, we think we got that one firmly in our heads. Now I want to show you how that perfectly applies to two different applications on your computer. First one, I'll just say you download an attachment on Gmail. Okay, so your application there is your browser. So your browser, you type in https://www.gmail.com. You get what you need from that, and your browser. I want to make sure I'm keeping in parallel here. I'm not getting too deep. Then returns back some images from your Gmail. Right. One of those is probably a little Google Doodle symbol. Here, that needs to be compressed. We're not going to send that Google Doodle out to everybody in full form. So the presentation layer is going to compress or decompress it. Same way with an application, or I'm sorry, with a download. When we send a download, there are ways to take a file, just like your zip file, and compress them down a little bit. Well, we do exactly the same thing to save your network a little burden, to save you a little cost for your carrier. Same thing happens here. So the presentation layer decompresses your download. Not to be parochial, but if you want to get a data saver and you have an Android phone, you can, well, or even on your computer, we have a little thing that will allow it to further compress things to save you a little extra money on your cell bill. Okay, so your sessionization bit. What is this? Again, this is, the analogy isn't perfect here, but because we don't have lots of multiple data streams to come through. But imagine that you're downloading something on your Gmail and then you switch networks, or you hit airplane mode, or you do something like that, and that download gets interrupted. Well, sessionization also handles that. It handles what's called checkpointing and saying, okay, well, you were here. We're going to pick up just a little bit before we drop the connection and then pick it up going forward, all right? So that is exactly analogous to, again, oh, sorry, Nikita, my phone fell out. Let's pick up where we left off. Right? This is literally exactly the same thing it's doing. Okay? So the next thing we're dealing with is the transport layer. Now again, just like certified mail here, we want to make sure that the download that we got is not corrupted. If you open a corrupted file, as some of you would know, like your Excels get too big and stuff gets wonky in them, and then it will make your application crash because it's sitting there waiting to pull more data in. So same thing, TCP is the equivalent of certified mail. That is sending out a packet that says, I want to know that you got this and you got the right size of this. All right? The network, this is a simple Internet Protocol envelope that we wrap this data in and say, okay, this is the information that I'm looking for. I'm looking for this download from this site. Here's how much of that I've already got. I want to make sure that you've got it, and please return it to this address as soon as you can. Thanks. All right. Your next layer is your data link layer here, and this, let's presume that you're doing this over your work computer or something like that. This is your Ethernet. Okay. Here, the communication from your computer is going to get bundled together, and it's going to be put in what's called a frame, which is roughly the same thing as a packet, sent over to your router. That is going to unbundle it and say, okay, well, this is looking to go here. All right, I'm going to put it in a new envelope or a new box, and I'm going to then ship it to Moscow. All right, cool. Gets to Moscow. This looks like it's bound for here. New box. All right, this is going down the street to 100 Kremlin Avenue or whatever. Okay. All right, and your physical layer here. This is something like multiplexing, which is just a way to send data that saves a little bit of space. Okay, but this is literally the pulses that are being sent over the line between your different routers. Okay, now this is one form of online communication. Again, we can do something slightly different here. Like, let's imagine that you were doing a Skype call off of your phone, and all I want to do is draw out here the different ways in which this can happen. Right here, the application would be what? And here I'd love to get some participation since I've gone through this twice. If you're doing a Skype call on your phone, what is the application layer thing? What are you opening? Skype. Yeah, that's right. So this is your Skype app. Okay. The presentation layer. What might we be doing in Skype or in Hangouts or in Apple Talk to try and make sure that that app is getting exactly what it needs? What do you think is going on here at this layer?
Well, your phone is running it, so it has to go through your phone.
That's true. Do we suppose we have any encryption on any of this? We don't want
password.
Probably not.
There is actually a bit. Mercifully, you're not sending nude pictures of yourself across the internet without anyone there. There is a bit of encryption there, which is good. There's also a bit of compression as well, which needs to be decompressed. All this is happening at this layer. So same thing. All right. Now the session. I already talked about this and gave this a bit of an example earlier. What are the different sessions that we're binding together for Skype?
Video and audio.
Video and audio, yeah. Video, audio. And timing. Okay. Now transport. Now, what's more important on a Skype call? Again, is it your perfect fidelity or timeliness? Like you just want the maximum number of packets through. Timeliness, right? Like it doesn't matter if you get the thing 3 minutes late, it's not good, right? So here we have something called the UDP, User Datagram Profile, which means you don't get any of those certified mail receipts back. It just move on. Like you lost it, we move on to the next one, okay? The next thing is the network layer. Here, I'll just give this to you. Basically, the world has standardized on the Internet Protocol. Like there is no other really robust addressing system that exists around the world anymore. Now let's imagine you're doing this on your phone. So here, obviously, Ethernet is not an option. What would be one of the communications or two of the communications protocols that we could use at the data link layer.
Wi-Fi.
Yeah, Wi-Fi. And what else?
Straight internet.
Cellular, right? So something like CDMA. Yeah, so. Okay, now down at this lower level, what would be the physical stuff that we're actually pushing out to send this through the air? Any ideas?
Like your router sending out radio waves? Or?
Yeah, that's right. So it's radio wave, technically microwaves on here. But yes, and it's sent in a given protocol like 802.11, which a lot of you would recognize from your router if you're on Wi-Fi, or something like CDMA, which you might also recognize that cellular phone companies throw around a lot. These are just different protocols for how data is sent when you have lots of collisions at this layer. At this layer, pushing over the air is a lot more complicated than this because you have lots of packets colliding in the air and the routers get confused and stuff, so a lot of resending. But in general, you'll see, like, at all of these layers, you have a choice for what you are able to select. I hope we've got like 3 minutes left for questions. That kind of elucidates what is happening through here. Any questions on this? I'm happy to do more sessions to dig into more of these, or encryption at what layer, or what is this? I'll try and keep them on class as well. But because most of this is publicly available, so all of this is publicly available. Any questions about this? Anything that doesn't make sense? All right. Go ahead.
I was going to say, quick question kind of related to the Skype piece.
Yep.
So the phones that we use now are VoIP phones.
Mm-hmm.
Typical VoIP phone, do you know if that has encryption on it?
Yeah, ordinarily, anytime that you would see a HTTPS, up here the primary protocol that is used is called Hypertext Transfer Protocol. Ordinarily, that has a little S behind it, and at the session level, there's something, I'm sorry, at the transport level, there's something called Transport Layer Security, or TLS, which does something called public-private key pairing, which will allow you to verify that the sender is who the sender is and the recipient is who the recipient is. And yes, ordinarily they would be encrypted. I haven't checked on ours. My assumption is that in addition to having air gaps between the network, that we also have encryption there.
Okay.
Any other questions on this stuff? If you want me to dig into this more, if we had time to do more of these, and I think depending on how my systems access goes, maybe I'll have more time to come up with more of these. Where is useful for me to dig into on this stuff, on transferring data between computers and computers? If you can just hit that pause button.